Assalamualaikum and good day, doctor. We are from group 7. In this video, we have shown the application of row reduced echelon form in electric circuit. Rref, which is stand for row reduced echelon form, are very useful in solving linear system problem. In this video, two examples of application that use Rref in solving the problem in electric circuit are shown. In physics, electric circuit problem can be interpreted as linear system equation. For this, we can use the combination of rules and formula to solve electric circuit problem, which are Ohm's law, Kirchhoff's law, and Rref. Next, we will look into the definition of Ohm's law. Ohm's law states that the electric current I flowing through a conductor is directly proportional to the potential difference across the ends of the conductor if temperature and other physical conditions remain constant, and the formula is V equals to IR. In Kirchhoff's law, Ohm's law states that the sum of voltage rise across any loop is equal to sum of voltage drops across that loop, and the formula is sum of voltage rise equals to sum of voltage drop. The first example of the application of Rref in electric circuit is shown below. An electric circuit is shown in the diagram. The question is how to get the current I1, I2 and I3 by using the Rref. The first step is from the circuit, the series of linear system equations are extracted, which are I1 plus I3 equals to I2, 15 minus 2I1 minus 4I2 minus 5I1 equals to 0, 20 minus 4I2 minus 2I3 equals to 0. To construct the equations, we can pick a point on the diagram to move along the circuit to the currents path, which are I1, I2 and I3. When starting at the voltage 15V, then move to 2 ohm resistor. The resistor would be a negative 2I2 because it moves with current. It makes it negative and it keeps moving to 4 ohm and finally 5 ohm resistor. The process is used for each loop in the circuit. Kirchhoff's law is applied to get these equations from the circuit. The second step is rearrange the equations and transform it into a matrix form. In matrix form, these equations form column and row for simplification in solving for each component. Next, the matrix A is simplified using Rref. First, to make zeros in column 1, accept the entry at row 1 and column 1. Subtract row 1 multiplied by 7 from row 2. In order to make zeros in column 2, accept the entry at row 2, column 2. In row 2, the values are divided by 11. Next step is, in row 1, the values of row 1 is added with values of row 2. Next, in row 3, the row 3 element is subtracted by 4 multiplied by row 2. Next, to make zeros in column 3, accept the entry at row 3, column 3. Row 3 is multiplied by 11 over 50. Then, in row 1 is subtracted by 4 over 11 multiplied by row 3. And finally, in row 2 is added with 7 over 11 multiplied by row 3. The reduced row echelon form are continued further until we get multiple zeros in the matrix. After we simplify, the final matrix of Rref is 1 0 0, 1 over 5, 0, 1, 0, 17 over 5, 0, 0, 1, 16 over 5. Thus, we can conclude that the current flow of the circuits are I1 equals to 0.2, I2 equals to 3.4, and the final one, I3, is 3.2.
Okay, next we will go to another example on how to calculate the current of the electric current by using Rref. Okay, given here on the left side is the linear equation of the circuit that we need to solve it into a simplest linear equation, into the simplest form, which is on the right side, so that we can convert it into a matrix form that we name it as matrix A. Okay, next is here is a matrix form of A that we converted from the linear equation previous one. Okay, as for row 1, column 1, we can see it is 76, row 1, column 2 is negative 25, and row 1, column 3 is negative 50, and last one, row 1, column 4 is 10. So, what is the first step that we need to do in order to calculate it by using Rref? Yes, by making zeros in column 1 except for the entry at row 1, column 1 that we call it as pivot entry. So first, we need to divide all numbers of the row 1 by 76. So that we will get row 1, column 1, number 1. So here, row 1, column 1 is 76. We divided it by 76, we will get 1. Same goes to row 1, column 2, row 1, column 3, and row 1, column 4. That we will get it into a new number when we divide it by 76. Okay, as for the second step, we need to add a row 1 multiplied by 25 to row 2, which is row R2 is equal to R2 plus 25 multiplied by R1. Okay, which means we need to add row 2 with row 1 that multiplied by 25, so that we will get a zero number to the column 1 and row 2. So same goes to row 2, column 2, row 2, column 3, and row 2, column 4, which means we'll get entirely of row 2 to a new number. Okay, the third step is add a row 1 multiplied by 50 to row 3, which is R3 is equal to R3 plus 50 multiplied by R1, so that we will get entirely row 3 to a new number. As for row 3, column 1, we will get 0. Row 3, column 3, we will get negative 663 over 38, and same goes to R3, column 3, and R3, column 4, that we will use the same method or step to get a new number. Okay, next is the fourth step, which is we need to multiply row 2 by 76 over 3631, so that we will get number 1 at row 2, column 2. Okay, this step, we need to know that we need to make zeros at column 2, except for R2, column 2, that we will need to make it into a number 1, while the other number at column 2, we will need to convert it to 0. So as for the sixth step, as for the fourth step, here is multiply row 2 by 76 over 3631. So we will get number 1 at row 2, column 2. And while row 2, column 3, we will get negative 1326 over 3631. And last one is R2, column 4, we will get 250 over 3631. Okay, as for the fifth step, we need to add row 2 multiplied by 25 over 76 to row 1, which means R1 is equal to R1 plus 25 over 76 multiplied by R2. So that we will get row 1, column 1, a 0 number. Same goes to R1, column 2, R1, column 3, and R1, column 4. Okay, next we'll go to the sixth step, which is R3 is equal to R3 plus 663 over 38 multiplied by R2, so that we will get entirely row 3 to a new number. So as for row 3 column 3, we will get row 3 column 2, we will get a 0 number. Okay, same step we apply to the row 3 column 3 and row 3 column 4, so that we will get a new number. So this step, remember, we need to make zeros at column 2 except for row 2 column 2, which is number 1. Okay, next is the 7th step. Okay, here is the starting point where we need to make zeros at column 3, except for row 3 column 3 that we will need to make it to a number 1, while the other number is 0 number. Okay, as for the 7th step is R3 is equal to 3631 over 242310. We need to multiply it to R3 so that we will get a number 1 at row 3 column 3. Okay, same step, same method we apply at row 3 column 4. Okay, next is 8th step. Okay, this 8th step, same one. We need which is R1 is equal to R1 plus 2825 over 3631 multiplied by R3, so that we will get a 0 number at R1 column 3, and same step we apply to R1 column 4. So we will get 5935 over 24321 by using R1 equal to R1 plus 2825 over 3631 multiplied by R3. That we will get entirely a new number to row 1. Okay, and the final step, which is the row 2 column 3, which is negative 1326 over 3631, we need to make it to a 0 number. How? Yes, by adding row 3 multiplied by 1326 over 3621 to row 2, which is R2 is equal to R2 plus 1326 over 3631 multiplied by RT, so that we will get 0 at R2 column 3, and same step apply to R2 column 4, so that we will get a new number, which is 900 over 8077. So that is the final step. So from here you can see, as for row 1 column 1, row 2 column 2, and row 3 column 3, it's all a number 1, while the other number is already 0. So it follows Rref, row reduced echelon form. Okay, here is the final answer of the row reduced echelon form of A. So we need to simplify it, where 5935 over 24231 is current 1 is equal to 0.245 ampere, and current 2 is 0.111 ampere, and current 3 is 0.117 ampere. So that is the final answer by using Rref, which is easy and simple method that we can use it in our daily life. So here is our references that we use.
Okay, that's all from our group 8. Thank you for watching this video. Hope you guys understand and enjoy this video.